So bubble sort is a very simple sorting method to sort a list of elements in an array. It is a useful method to sort a small list of elements. You don't want to use this for larger list because there are better methods out there, and the complexity of bubble sort is much higher than other methods out there. So first we will go through this example step by step to sort this list I have here on the screen, and then I will show you the pseudocode implementation of this method, and we will analyze its complexity. Finally, I will show you a programming language implementation of this method. Okay, let's begin. So here I have a list 7, 3, 9, 5, 2, 4. And I want to sort this in ascending order. And the final result I'm expecting to see is 2, 3, 4, 5, 7, 9. So what bubble sort does is, at every step, it will push the largest element in the list towards the end of the list. So you're bubbling the next largest element towards the end of the list. Okay, to do that, what we have to do is let's start with a pointer here, the first location. And then we need to compare the first two elements. Since we are sorting this list in ascending order, we have to swap these elements because 7 is larger than 3, so we're going to swap them. So when we swap these elements, we get a new list. The new list is going to be 3, 7, 9, 5, 2, 4. And then we will move the pointer to the next location. The next step, we will compare 7 and 9. Now there is no change because 7 is less than 9, so we don't have to make any changes here, so no swapping. So we'll move the pointer to the next location. And then we will compare 9 and 5. Now we have to swap because 9 is larger than 5, so we have to push 9 towards the end of the list. So the list would change now to 3, 7, 5, 9, 2, 4. So we have a brand new list now. So let's move the pointer to the next location. And then we're going to compare 9 and 2. Since 9 is larger than 2, we have to swap 9 and 2. So once we swap, we get a new list. It's going to be 3, 7, 5, 2, 9, 4. We move the pointer to the next location and compare 9 and 4. Since 9 is larger than 4, we have to swap. So we change the list again. So it's going to be 3, 7, 5, 2, 4, 9. So we pushed 9, which is the largest in the list, to the end of the list. So this 9 will not change anymore. Stay as it is. Okay. So now let's continue. So in the next step, what we're going to do is we're going to compare, starting from the beginning, 3 and 7. Because we start the pointer again at the first location. When we compare 3 and 7, no change because 3 is less than 7, so we don't have to swap. So we're going to move the pointer to the next location and compare 7 and 5. Since 7 is larger than 5, we have to swap. So the new list is going to look like 3, 5, 7, 2, 4, 9. We don't have to make any change to 9 anymore. So let's color this like this. So in the next step, we are going to move the pointer to the next location and we'll compare 7 and 2. Because 7 is larger than 2, we have to swap. So let's swap. So swap. 3, 5, 3, 5, 2, 7, 4, 9. Again, let's color this 9. Okay. So we're going to move the pointer again to the next location. And we'll compare 7 and 4. Since 7 is larger than 4, we are going to swap again. So 3, 5, 2, 4, 7, 9. Since we are not going to go any further down because we already pushed 9 to the end of the list, which is the largest. And we got the second largest element now, so we are not going to touch 7 anymore. We're going to leave 7 as it is. Then we will restart our pointer to the first location. We'll compare 5 and 3. No change again. Then we are going to compare 2 and 5 after moving the point to the next location. When we compare 2 and 5, 5 is larger than 2. So we have to swap. So 3, 2, 5, 4, 7, 9. Let's color these guys. Make them nice. Okay. Then we are going to move the pointer one location forward. We'll compare 5 and 4. 5 is larger than 4, so we are going to change the list again. So 3, 2, 4, 5, 7, 9. So now we are not going to proceed any further because we got the largest 2 elements towards the end of the list. We cannot go forward anymore. So we're going to make 5 as the third largest element and then keep them safe at the end of the list. Now we have to restart this process. What we can do, we move the pointer to the first location again. And we compare 3 and 2, and 3 is larger than 2. That means we have to swap them. So 2, 3, 4, 5, 7, 9. And let's color these. After swapping, we are going to move the pointer to the next location and we will compare 3 and 4. There would not be any change because 3 is less than 4. And now we got another element as the fourth largest element. Let's color this. Right? Then we'll move the pointer. So let's write the list down again. 2, 3, 4, 5, 7, 9. Alright, and then we'll move the pointer to the first location. And we'll compare these two elements. No change, no swapping. That means we got the fifth largest element for this array. And we don't have any more elements to sort because we have only one element left. So we got the sorted list. So when you compare this to the list we were expecting right here, it's 2, 3, 4, 5, 7, 9. So we got the array sorted. So this is how bubble sort work. Okay, let's do a pseudocode implementation of this method we just followed. So if we look back in the example, first we went from left all the way to the right of the array, right? All these steps. So we had total of 6 elements in the array. So we went from 0th index to the 4th index. That's 5 elements in total, right? And then we switched the pointer back to the first element. And then we went from 0th index to the 3rd index, right? And then we switched it again to the first element. And then we went from 0th index to the 2nd index. Then we switched back. And they kept on doing it until we have no more elements left and we cannot move our index anymore, right? The last time our index was at 0 and we couldn't move the index anymore, right? So we did this 5 times total. Okay? So 5 times we have to move. So that means we have to have a for loop which will run from index 0 to 4, right? And inside that, we need a for loop which will run from index 0 to the list number of elements, which is 6 now, minus the first array's index minus 1. So let's do this. Let's implement this pseudocode. So we'll run a for loop for I from index 0 to less than, if I assume that n is the number of elements, let's say n minus 1. Then I'm going to have another for loop for j from 0 to less than n minus I minus 1. And then we can compare. This is the comparison we're doing, right? The comparison we did everywhere. So we can compare if array of j greater than array of j plus 1. So we compare, for example, the first element with the second element. If they are greater, if the first element is greater than the second element, then we had to swap array of j and array of j plus 1. And that's it. We're done. So in the first step, our index is going to be 0. So I is 0, right? In this case. And your j is also 0. And then you compare array of 0 to array of 1 and then swap. And then you move j from 0 to 1. So you go to the next location, compare 7 and 9. You don't swap because this if statement would fail. It'll go back and increment j. Now j is going to be 2, right? So move the pointer to this location and compare 9 and 5. Then you continue and reach at this point. This is going to be, here n is 6, number of elements is 6, I is 0, 6 minus 0 is 6, and minus 1, so 6 minus 1 is 5, so less than that you'll go all the way up to 4, which is 4, right? So you have to stop this for loop at 4. And then you go switch back because you're done with the inside for loop. Then you will get out of the inside for loop and go back and increment value of I, make it 2. That's the second pass. And then you will come down and reset your j to 0 and reset your pointer to this location, and then it'll keep on continuing. So what you need to do is you need to try it out by sending each element through this for loop, and you will understand it better. You have to try it out manually. That's the best way to test your pseudocode. Now let's do an analysis of the complexity of this algorithm. The complexity analysis of this method is very straightforward. We have 2 for loops here. The first loop is going from almost 0 to n, or n minus 1. And the second loop is also going from 0 to n minus I minus 1. So it's pretty easy to see that the complexity of this method is n squared. Right? So this is the complexity of the method, because you have 2 for loops and elements are going from left to right of the array twice in 2 loops. So the complexity of order of n squared. Like I said before, this algorithm is useful for sorting a small list of elements. The list is larger, like for example, if you have a list of 1,000 numbers, the complexity is pretty high. And there are better methods to sort if your list is large. And we will learn those algorithms in another video. So now what I'm going to do is I'm going to show you a programming language implementation of this method.